Bien. Bonjour à nouveau. Je suis très heureux d'accueillir aujourd'hui le professeur Mariano Sigman, qui est un grand ami, un ancien du laboratoire et un très grand chercheur. J'allais dire, et néanmoins un très grand chercheur. Mariano Sigman est un physicien de formation, physicien qui s'est tourné vers les neurosciences. Il a fait sa thèse avec Charles Gilbert à New York, aux États-Unis. Entouré d'ailleurs dans son jury de thèse de très grands noms comme Michael Posner par exemple. Et ensuite il est venu en postdoc en France et il a travaillé pendant plusieurs années au laboratoire à l'époque où nous étions à Orsay, au service hospitalier Frédéric Joliot, et on a travaillé ensemble sur des questions d'architecture cérébrale et en particulier de la capacité du cerveau de faire plusieurs tâches en même temps. Et on a constaté effectivement qu'il y avait ce goulot d'étranglement central du cortex frontal et fait beaucoup d'expériences là-dessus. Et puis Mariano a décidé de retourner à Buenos Aires, en Argentine, son pays d'origine, pour y fonder ce qui est encore aujourd'hui un des plus grands laboratoires d'Amérique du Sud consacré donc aux sciences cognitives, et avec cette capacité particulière d'enseigner pour les physiciens des notions de sciences cognitives et de neurosciences, de sorte que c'est une recherche extrêmement originale, je crois, on peut dire, que tu mènes, Mariano, qui est inspirée par la physique et qui essaye d'appliquer à des questions très difficiles de sciences cognitives, même les plus élevées, on va le voir aujourd'hui, des paradigmes de la physique. Et en particulier la question de la conscience, sur laquelle on a aussi travaillé ensemble, et puis la question de la représentation du sens des mots et du sens des phrases, qui, vous savez, est un challenge encore aujourd'hui pour les sciences cognitives. Alors, avant de te laisser la parole, Mariano, je voudrais juste te dire que Mariano est aussi l'auteur d'un livre important qui s'appelle « La vie secrète de l'esprit », « The Secret Life of the Mind », c'est ça en anglais, et également en espagnol, il paraît en premier en espagnol. Ce livre paraîtra dans quelques mois en France, on l'espère tous en tout cas, et c'est un livre qui fait un panorama des recherches de Mariano dans le domaine donc, de la nature de l'esprit. Et aujourd'hui, The Past and the Future of Consciousness. L'exposé sera en anglais, mais vous pourrez poser vos questions en français si vous le souhaitez.
Bon, merci Stan. Je vais commencer en français seulement pour que vous voyez pourquoi je ne vais pas continuer en français surtout. C'est rouillé mon français, donc je pense qu'il va falloir quand même que je trouve des mots assez précis pour ce que je voudrais dire, qui n'est pas très précis en soi. Et donc je pense que je ferais mieux de passer en anglais, mais quand même je comprends, vous pouvez poser vos questions en français, je serai très content de les répondre. Et d'essayer, si jamais vous voulez que je fasse quelque chose en français, je le ferai quand même. But I'm going to switch to English because I think it's going to be for an hour easier for me. And I'd like to start with a very general idea about natural sciences and maybe all science, which is that I think at least a way I have of seeing natural sciences and biology, which is finding diversity within similarity, or finding uniqueness and diversity within regularity or within universality. So you can think biology is based on the idea that there is some commonality to how matter has constructed life. So there are some similar biochemical mechanisms, similar molecules, proteins, DNA. There are very fundamental ideas, the idea of reproduction, the idea of catalysis, the idea of enchainment or contention or boundaries. Those are all essential ideas about life. Yet we know that life happens and is instantiated in all sorts of different forms. And this is the essence of biology, understanding how life can be so different and at the same time so similar, this coexistence between rules and diversity. And this, I said, is, I mean, we can go on with this idea for all, of course, all science, but I think it's also particularly true in cognitive neuroscience. And I think that this has a historical pertinence and historical relevance, because I think that it has divided a little bit the way people in different traditions have seen human psychology. So one is an idea of uniqueness of the self, of uniqueness of humans, what's unique about humans, and what's unique about each one of us, what makes each one of us us. We could do a whole lot of science based on that. And there is other, in this dimension of uniqueness and diversity, there is another way of seeing things where some people are more interested in seeing what's common to all of us. What are the things that are shared in human cognition or in animal cognition or in the capacity of producing maybe any form of cognition, even artificial cognitions or cognitions in different places. And when one goes in this domain, and there are many people like Stan himself, or Ghislaine Dehaene-Lambert, or Véronique Isard, who is also here, that have tried to, in the domain of human cognition, have gone on this way of understanding what's common to different forms of human cognition. There are many ways that one can go about this. One way is going on to different individuals. We can do experiments in different people and try to see what's different and what's the same. We can go farther. We can go to different cultures. We can go to very remote cultures that have a very different social and educational experience and see whether they have the same form of reasoning, whether they have the same form of math, etc., etc. We can also try to go to other species. And one thing that has been in the essence of understanding what are the structural columns of biology is going to the past. So when we want to understand the essence of life, a very fundamental idea is going on the long history of life and trying to see how life goes many, many years ago, when yet it had not unfolded in the present in such sophisticated diversity and such sophisticated complexity. And of course, the same idea is also true for psychology or for cognitive neuroscience. We can go on the history of psychology and trying to understand the history of human thought. What are the things that we think should be the same for all humans, regardless where they are, regardless in what time they were born? And I think I'd like to do this experiment of trying to probe the intuitions. I haven't done that. But I think that we would agree that there are certain things that should be present in reasonable forms of human cognition, regardless of space and regardless of time. So for instance, the idea of having a memory. I think that we agree that having a memory is an essential part of human cognition. Maybe the capacity of extracting rules we saw today is something which is definitory of how humans actually. We could go on to more phenomenological aspects of human cognition. Maybe the capacity to imagine. Maybe the capacity to do logic or to reason. Maybe the capacity to dream. Have there ever been humans that were not able to dream? Has there been a moment in history? Or is dreaming something which is essential part of human cognition? And another capacity, which I think that we would all share, I think the majority of us would have the intuition that it's a shared capacity of human cognition, is the capacity of being conscious, capacity of being aware. I think that we have the intuition, and again, it's an intuition that has to be proven, if possible, if there's a science that can test that consciousness, in a similar way to the way we perceive it and recognize it today, is something that must have been there throughout the course of human history, and not something like, for instance, reading, that is maybe something that appeared at a very precise moment in human history. Now, the question is when this program of trying to look at the history of life is done in biology, it's based on remainings that these species that lived many years ago have left that we can observe now to try to retrace how life was many years ago. So those are fossils, essentially, different forms of fossils, but they're traces that, again, we can use to try to unfold and reconstruct the history of life. And of course, in the history of human thought, those fossils are more labile, because the expressions of human thought actually are not so easy to find in the course of history. But of course there are. So we can think that all language, all the writings of human cultures to the moment that we have them are fossils. Of course, the drawings, the constructions, every single piece of human activity is something that we can try to go back and retrace and do some form of cognitive science or experimental psychology based on very small data sets that are the ones that are left over from many years ago. And this is the path that I would like to go on the first part of my talk, and which is trying to think how to go about the idea of doing an experimental psychology or a cognitive science of what were the thoughts of our ancestors many years ago. And of course, many people have done that, and one which I think is a very fundamental one, where I would like to base the essential part of the more, so to say, it's a proto-theory. It's not quite a theory, but it's at least it's a frame, was Julian Jaynes, that many years ago went onto this task. What he did was he took the readings, the books written by different cultures in the something like 3,000 years ago, when in the first productions of consistent and systematic productions of human writings, and he read them, and he tried to analyze. He did like some inverse psychoanalysis from these writings, or inverse psychology, if you would like better. So what he tried to say is, what are the thoughts of the persons that are actually writing these books? And he found a trace. He found a pattern. He discovered, at least he claimed, that there was a systematic observation that was consistent in different cultures, in different traditions, and essentially it was the following. What he found was that I'll give you two examples now, so you can see that, for instance, he gives an example, this is an example in the Greco-Roman tradition, so he goes, the impulsive, reflexive heroes of the Iliad, driven by passions, insufflated into them by the gods, give way, as time goes on in these writings, to the wily, cunning Odysseus who outsmarts Polyphemus and leads his men to Sicilia with a bad conscience. So you get an idea that what's going on there is agents, humans, that, and I'll go in more detail into that, in the beginning are not very volitional. They just hear voices and they act a bit madly on what they are hearing. And eventually, as time goes on, becomes more reflexive and become more self-aware of the thoughts that they're producing. And now in the Judeo-Christian tradition, the wrathful interventionist God of the Old Testament, who expels Adam and Eve from the garden, is followed in time, as the Bible goes on, by the rich inner life of the New Testament, where Jesus asks the accusers of an adulterous woman to examine their own guilt. So you go, again, this is Julian Jaynes, and I'll go into much more detail about this now, but his point was that, and you can see it's very anecdotic at this point, and this is exactly how it was, is that in the beginning of all these writings, the humans described there consistently in different traditions, in different books, again, as a regular observation, began expressing their actions as if they're hearing voices that guide them on what they have to do. And as time goes on, they begin to recognize that they're the creators of these voices, that they're their thoughts and they're responsible for what they do, and they should assume guilt, and they can even act, and they can even say, that's something I want or I do not want to do. Now, this is something that's interesting because today, and this is a picture here that you have of Apollo preceding, again, the idea of in wars where there were the gods that were leading the warriors to what they were doing. And this is, if you think in the Homeric text, the relation between Apollo and Hector is very interesting because Apollo appears as a guide to Hector. Whenever he needs to do something, Apollo is there to tell him what he has to do. There are voices that he's hearing, but they're not manifested always as a god. Sometimes Apollo is a god, but sometimes Apollo is a friend. Sometimes Apollo is a family member. Sometimes Apollo is someone that he cannot recognize. So if you could take that seriously, and again, I put this between quotes, that's how it has to be now. If you could take this seriously, and if you're a psychiatrist, what you could say is Hector is schizophrenic. Hector is hearing voices that are telling them what he has to do. These voices appear, and especially appear in difficult moments in which he has to do difficult things. He does not realize that those are his own creations, and he perceives these as different projections of different agents that are telling him exactly what he has to do. So this led Jaynes to, I think, a quite interesting idea, and one that I first read when I was doing my PhD, working in, so to say, much more grounded areas of neuroscience. But this was to me a very interesting and provocative idea. It was the thought that maybe consciousness, the way we perceive it, we all feel, or the majority of us feel that we are the agents of our actions, and we all produce internal thoughts. We go into the elevator and we start saying, tomorrow I should do something with that, or I have to finish this task which I didn't do, or I wish the result of this game would have been different, or I wish this person would have responded me differently. We create all the time, we have all the time mental creations, but we have the ability, an ability that actually appears to be obvious, and it's not at all, of recognizing that we are the creators of these voices. And in the moment that we do that, we have an agency, we have an introspection, we can think about our own thoughts, and this allows us actually to act on them in the way that we think we want. So this is very different. This is an interesting idea, at least for me when I first read that. I think that the first intuition of how is the mind of a schizophrenic is that they are actually producing much more hallucinations than a normal person, than a non-schizophrenic person. Another idea which is one that Chris Fried has pushed, and many other cognitive scientists, is that they produce essentially the same mental content. They're daydreaming all the time, as we do. But the main difference is that they cannot recognize that they're the creators of these voices. And when this happens, and we have inner voices that we don't have agency for, it's like a dream. It's like this is coming from somewhere else, from the gods, from the muses, from friends, and then schizophrenia comes there. So in essence, and just to put it short, again, it's a long story made quite short, Julian Jaynes' claim, and it was a very wild one, and it remains a very wild one, so I'm aware that this is the beginning of hard science, was that about 3,000 years ago, human consciousness was very different. It was non-volitional. People created voices, and they did not have the capacity of fully understanding that they were the authors of these voices. And so the world was like a big garden of schizophrenics. It is as if it was really populated. And his point was, if I read how characters I described in the books of all traditions, then that's how they are. And I see a progression with time of characters understanding that I am the responsible of the thoughts I have and the actions I make. So we wanted to, this was an idea, and to me it was a very seductive idea. It was an interesting idea, maybe wrong, but at least an interesting idea. But what was clear to me, and it may be clear to you, is that this is not science. This is just picking on some anecdotes to make interesting claims. So the question to me, and it was one that remained for a long time, was, could we convert this idea into science? Could we start beginning asking these questions in a way that seemed not just as fiction, or not just as theory, or not just as philosophy, nothing wrong with that, but it's a different way of addressing knowledge, but could we make science from that? And the problem, there are many problems with this, the scarceness of the data, we'll go on to this later, but the main problem was the following. What we wanted to understand, let me give you an example which will make this clear. This is a paper made by Mitchell, by the group of John Mitchell and other ones, when they capitalized on the idea that Google had digitalized essentially a very substantial part of all the production of human texts. And then you could do a very simple game. You could look in history and just look at the frequency of different words, the word you're interested in. Like you could look at the frequency of scientific words, or you could look at the frequency of philosophical words, or of content words, or verbs, regular, irregular. You could look at the dynamics of words throughout the expression, the integral expression of human culture. And I'll just give you an example to show you how useful this can be, but at the same time how limited this is if we want to ask questions like the one I presented just before. So this is the history, the dynamics of the frequency of the word slavery. And you see it's a word that's been spoken, it's been there. What you have here is essentially a relative frequency given to all the number of words. So it's the density of the word slavery compared to the probability of finding the word frequency in a given text. And you see it has peaks. And these peaks correspond to different moments in which slavery was an issue in the United States and in the world, a political and ideological issue. So you can see how just by counting words, you can understand, you can do a bit of the history of sociology. Of course, it's completely incomplete, it's just a very small picture. And you can see things interesting, like here was the Civil War, which was a civil war which was strongly based on the concept of slavery. But you see how actually the notion of slavery actually started many years ago. And it built it up, and you can start questions of can I predict things? Can I predict the explosion of social events given the density of a word? So this is interesting, and this was, here you have another example. This is one I think it's quite cute, because you have here, this was the density of the word, the Great War, which of course at 1917 in the First World, this was the Great War, but then there was a Second World War. And then the Great War was not the Great War anymore. And so you can understand how in history, humans have reorganized and rethought this is something which is quite close, and we have a direct relation with that, but we can start seeing how you can understand how people saw things and how people understood things semantically in history just by counting words. So this is quite powerful, but for the case we want to study, there is a problem, because what we wanted to study was the history of introspection in the human culture, the history of the capacity of humans to understand that they're the owners and the creators of their own thought. But the problem with this is that the word introspection does not appear one single time. I mean, I would like to measure the history of introspection, and what I would find is there's a peak with Freud, essentially, or with a... And this is not something that will be in itself very interesting, because the idea is that to know that someone has introspection, they do not have to declare that. And this is the essential problem with semantics, which is that I can be talking about anything, about music, without naming a single time the word music. Yet you know, because of the way I'm surrounding this concept, that this is what I'm speaking about. So the technical difficulty that we had, which became a science in itself, was how to know that someone's speaking about something when they're never mentioning this one particular thing. And so for this, I want to make, this is where I'm going to go. So we're going to leave the question of Julian Jaynes for a while, for 15 or 20 minutes, about the history of introspection in human culture. And now we'll go on a more pedagogical, or slightly technical also, but with a pedagogical aim of understanding how to forge this idea of someone speaking about something. And for this, we go onto the domain of the space of meanings, of trying to understand how meanings are organized in a particular space. And I think that a good example, and this will take me 15 minutes, and then we'll come back to this. So we'll leave the problem of the history of consciousness for 15 minutes, and we'll focus now on the issue of mapping semantics. And I like this particular example, because I think, first, because it obviously has to do with the history of Stan, but which is a very particular domain of semantics, which is mathematical cognition or mathematical concepts, but also because it makes very clear the point that I want to make. So let's imagine I draw this line, like 100, 300, 500, and 700. Those are 4 concepts. And I've placed these 4 concepts in space. And I've chosen to do that in a way that I think it's quite natural for how you may represent these concepts. I could have done it in a circle in different ways, but I chose one which I think will fit very well with the mental organization that you have about numbers. The question is, where's the number 1,000? And we would all agree very rapidly, it's not there, yet you have identified what's the geometry of this space in a second. Then there are questions like, what number is here? And 8, 9, 10, 11, 12. Doesn't take, again, we don't need to make anything explicit to actually identify what's the geometry of this. Is 1,300 left or right from, all those are questions that are tremendously easy. Now let's try to think that for semantics. Let's generalize this, not for the number concepts, but for all sorts of concepts. So for instance, here's the concept of hope, there's the concept of logarithm, and there's lettuce. Those are 3 concepts that I have mapped, and we can ask the same questions. For instance, where is elephant? Where do you think is elephant? Would it be to the left or to the right? It's close to lettuce, probably, because at least it's a living thing. I mean, of course, it's very difficult, but we already have a very crude geometry, a very crude notion of an organization of this space. What meaning is here? What meaning would be there, close to lettuce? Tomato, for example, because lettuce and tomatoes are in salad. So we start getting an idea, although this looks like a completely illogical problem, like a question, we all have an idea of maybe the organization. Isn't it closer to hope or to lettuce? This is one example of diversity within regularity, of course. This would be a question that would be very different for all of you. So you see the idea of the point where we are going. We would like to try to come out with a space that represents all words on a way that their distance, how far they are, represents their semantic similarity. And they do so in a way that mimics or reflects the way we organize these spaces in our mind. And this is a complicated empirical question. But it's one that has been there for a long time. It's not new, of course, like all these questions. And I would like, I'm very happy to be here at the Collège de France, and I would like to take the opportunity to bring Borges, Jorge Luis Borges, our favorite author, who's always on a way with us, to the college. And Borges had a text called the Analytical Language of John Wilkins, which I think is maybe the most beautiful description of the path or the questions I'm speaking about now, and I strongly recommend it should be cited there. I'm sorry, it's the Analytical Language of John Wilkins, and this is Borges. And in this essay, he goes on this idea of how to construct a semantic space. And so he goes like this. I'll read. It's going to be it's a bit of a spoiler, but I'm going to read just 6 paragraphs of that. So he goes, Descartes had already noticed that using the decimal number system, it may take only 1 day, actually way less than a day, to learn how to name all the numbers up to infinity and how to write them down in a new language, namely that of ciphers, that of symbols. So we have a symbolic representation for which a concept that we've never seen before, we've never heard before, like the number 3,726,398, which pretty sure none of you have yet heard in your life or thought about, immediately gets answered to what it is, because we have a notation that conveys meaning through symbols. Now, what he asked is he suggested the creation of a language similar to this system, a general language organizing and covering all human ideas. Could we extend, and could there be a way of writing words so that when you see a word for the first time, it's as if it were a number. You understand what it is from how it's notated, even if it's something that you've never seen. So he goes on to John Wilkins, and this is a real story. Borges, of course, has all the time fiction mixed with, but John Wilkins actually, in the 17th century, actually tried to solve this. And the way it's pretty easy to understand how, I think it's very natural to think how one would go about this. And many people have done this in the history of formal languages. So he divided the universe in 40 categories or classes, this being further subdivided into differences, which was then subdivided into species. So you go there, an essential notion which will come here, which is a notion of a tree. Again, we build things in semantics using recursion. A means animal, AB is a mammal, ABO is a carnivore, ABOG is a feline, ABOG is a cat. And so if I gave you this and I told you this is an aboja, and you don't know what an aboja is, you already know that it is a carnivore, it's a feline, and it's probably close to a cat. So you see that you have a representation of words that's consistent and conveys meaning through how they are notated. Now Borges, which of course understood these things very well, after presenting this idea, immediately destroys it, as you're probably also seeing the problem. So he goes, once we have defined Wilkins' procedure, it's time to examine a problem which could be impossible or at least difficult to postpone. The value of this four-level table, which is the base of the language. What are the categories? I mean, I chose animals to separate things, but would this be a universal way of separating things? So he goes, these ambiguities, redundancies, and deficiencies remind us of a certain Chinese encyclopedia, which does not exist. In its remote pages, it is written that the animals are divided into, and so this is the categorization in this Chinese encyclopedia. So belong to the emperor or not, which of course is very important. I mean, this is a fundamental difference in this particular culture. Their involvement or not, because animals, that's how animals are presented. They're tame. This would be relevant in all cultures. They are aggressive or not. They're sucking pigs, which in this particular culture was a very important division. Syrians, fabulous, stray dogs, included, I mean, very Borgian concepts. Frenzy, blah, 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 innumerable, drawn, a very, and so on. So Borges presents, and look, I think this is quite nice because it's what I presented in the very beginning of the idea of regularity or diversity within regularity. What's regular here is that we break semantics into categories. What are these categories is something that may have some commonality, but may change a lot depending on the history we had, the education, the culture, the society, et cetera, et cetera. So this is what Borges says in a much better manner. And I think it's to me, when I first read that, this was a very essential fuel for doing science. So I want to share it with you. It's like a little present that I would like to offer you. It was a very fundamental reading for me. So he goes, the impossibility of penetrating the divine pattern of the universe cannot stop us from planning human patterns. The fact that we cannot understand all of it doesn't mean that we cannot go on and try to search certain regularities which are going to be useful, even though we are conscious that they're not definitive. I think this is a very fundamental and essential definition of science. The analytic language of Wilkins is not the least admirable of such patterns. The classes and species that compose it are contradictory and vague. The nimbleness of letters in the word's meanings to divisions and division is no doubt gifted. So again, in a very elegant manner, to me, the idea of finding something essential within something that can vary all the way along. So this was Borges, and now I would like to present a much more modern, although yet has maybe 50 years, so modern quotes between something that has already 50 years of research of addressing this problem. This was done by George Miller and his group at Princeton, and it was a very, it was a massive effort that they did. They essentially tried to construct the shape of the lexicon by hand. So they tried to essentially place every single word out, every single concept out there. Concepts and words are not quite the same, and link them by different semantic relations. And so just to construct by hand, as if it were a semantic dictionary, this space of meanings. So this is related with this, and this is related with that, and it's related with this other thing. And so they started doing something which is close to the Borgian idea. The first notion of semantics is this relation called the relation of being an hypernym of something, being of the class of something which is above. When you go to a dictionary and you read the analytic language of John Wilkins, seems like something that's quite far from our actual reality of how we organize language, but it's very essential in how dictionaries work. When you go to a dictionary and you read, for example, say a tiger, it will say it's a feline that's found in these places in Africa and in India, and it has stripes, yellow and black, and blah, blah, blah. But there are many things that it doesn't say. It doesn't say that it has a metabolism. It doesn't say that it breathes. It doesn't say that it reproduces. It doesn't say maybe that it has 4 legs. Why doesn't it say all these things? Because all these things are the properties of the hypernym to which it belongs. It's a feline, hence it's an animal, hence it has cells, hence it has a metabolism, and so on. There's no need. So essentially the way dictionaries work and the way potentially how we organize a lot of meanings in our minds is when we find something is we know to which class it belongs, and so it has all these commonalities, and then we need just to describe what's specific of this particular entity within this one broader class. So this is what you have here. So there are vehicles, and vehicles are broken into motorcycles and cars are broken into ambulance and minivans. And if I tell you an ambulance what it is, I'll say it's a car that's used for health in blah, 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 and again, the same idea. So this is a very backbone of how we organize meaning, and again, it's going to come 1 or 2 more times during my talk. Another idea of how meanings are related, and this is the second important semantic relationship, is a relation also of belongingness, but not of a class belongingness, but of substance or matter belongingness. So you could say, for instance, car is related with seat or with accelerator or with steel, because it's made of steel. Now, seat is not a car, it's part of a car. So this is something which is very different. It belongs to the class of, but this thing is made of, or that thing is used to make something which is larger than that. And then there's another fundamental relationship, which is the relation of antonym, being a contrary, being an antonym, so white, black, and this is actually a very strong, it's the strongest relation when it comes back to very rapid association. So when we humans make links, semantic links, the stronger and more typical one is the link of antonymity. So this is essentially, it's more complex than that, but this is essentially how concepts are related. They can be related by being part of something, by being made of things, so used a substance to make them, or by a relation of negation. And you can see there that when one does that, again, I said Feldbaum and Miller and all the psychologists in Princeton, they did by hand all these drawings of these relations, and they constructed something called WordNet, which is still out there, in which the idea was that WordNet was a sort of graph that tried to mimic how we organize thoughts in our mind. Things were related in a way that we think that humans tend to relate concepts. Now, again, I remember this was, maybe I was in my PhD. That must be like 20 years ago. Maybe that was 1998 or something, in the end, before last century. And Guillermo Secchi, he's my scientific brother. We've been together for many, many years always, and we've done so many things together. And he came to me and he said, I have it. And I asked, what do you have? And he said, we were thinking about language for a long time, and we were looking for trying to understand, again, coming back from James and trying to think how we could construct the space of meanings. And he said, someone has done it for us. Again, we hadn't seen that, and he said, Miller and Feldbaum and so on have constructed WordNet, and so now we have this huge network of how meanings are organized. And the first question we pose there, it's a very natural question, is how is this space organized? How is it? How many dimensions does it have? How much does it take to go from one meaning to the other one? Are meanings typically surrounded by a lot of meanings? It's a very curved space where to go from one place to the other one, it has a very weird geometry. So you want to understand how the geometry, the topology of this space. And this is a graph. And graphs can be navigated, but there are all sorts of graphs. And so now I'll make another zoom in to go into the mathematics, very briefly, again, not too long, just 2 minutes. But I would like to be as detailed as possible with this, to give you the idea of how can we actually measure the structure of these objects, of graphs. This is quite basic mathematical theory, but again, I assume that at least for a good part of you, that's something that's not necessarily known. And then we'll come back to the structure of the lexicon, and then to the history of introspection, and then from there on close to the exit of this. So those are two graphs that those are two different spaces. And you can see that these two different spaces have different shapes. It takes and they belong to two extreme classes that have been favorite icons for the mathematical theory, mathematical graph theory. One is a random graph. Yeah. So one is a random graph. So it's a graph in which like those are nodes, and links are what are the bridges that you can use to go from one node to the other one. And the bridges here are just thrown at random. So essentially, and you can see that there's not a lot of order here. This is one thing which is obvious. And this is quite the opposite. It's a highly structured and ordered graph. It's a crystal. It's something in which there is a lot of notion of locality, in which if there's a neighbor, then neighbors and neighbors of neighbors and so on. So those two graphs are good enough to have an idea of all what I want to say today. And they've been used as battle horses to sample a much more complicated space, which is the space of all graphs. So you can see very rapidly properties of these two different graphs, which are necessary for what I want to tell you. The first one is that structured graphs, because they're so local, it takes a long time, or it takes many steps to go from one place to the other one. So if I want to go from one place to the graph to the other one, then I have to jump one. There are no shortcuts. They have no airplanes. They have no way of going hyperspace, of going from one place of the graph to the other one. They're walking graphs. While these ones, it's the other way around. It's full of links that actually take you, from New York to Rio de Janeiro, and from Rio de Janeiro to Paris, and from Paris to Johannesburg. It's like, because it doesn't have a notion of locality, there are these jumps that can take you from one place of the graph to the other one. So these structured graphs have large diameter, and these graphs are actually short-lived. And the other essential mathematical property is that, and it seems to be a trade-off between these two things, that's how it was for a long time in the history of the mathematics of graphs, is that these ones have what's called clusters. So the notions, and this is very typical of social graphs. So I know Stan knows Véronique Issard, and I know Véronique Issard because we're in the same place. So the idea that if A is friend with B and B is friend with C, then typically A will be friend with C. So those are called clustering, and they form local structures. There are graphs in which there's different nested sizes of structures. While these random graphs do not have this. This one can be friend of this one, and this can be friend of that one, but that doesn't mean that these two nodes will be connected between themselves. So essentially, for many years in graph theory, the two graphs were structured graphs, which had high clustering, were structured, that's in their name, but it took a long way to walk from one to the other one, and random graphs that were unstructured, that had no clustering, but had a very short distance, a very short diameter. And the paradox with this and what was found in nature is that, for instance, social graphs and most graphs that you construct in nature are clustered, but are also short distance. So if you go to a friend of a friend of a friend, in 4 steps, you've gone from one extreme of the graph to the other one. So it seemed like these two categorical descriptions of graphs were not good enough to describe the most typical graphs of nature, which were actually small words. And then Watson Strogatz in 1998 came with what was a tremendously influential paper. It changed completely a whole lot of domains in a moment in which network theory was exploding because of the internet and so on, in which they had it's quite interesting because they had this tremendously simple idea, but it changed the whole game. What they found was the following, which was that if you begin with a graph that's structured, so it's very clustered, and you just put one link or a small number of links, they don't need to be too many, that actually makes a shortcut between one extreme of the graph and the other one, then it's like you had a very long graph and you fold it in 2. And you do that 2 or 3 or 4 times, and because this is exponential, you're just reducing the diameter of the graph by a lot. You're compacting, you have a graph, it's very long, and you join this extreme with this extreme, and then the diameter of the graph divides in half. And you do it again, and again it's half of the half. You do that 4 times, and already the graph is very short. Yet the mean clustering has not changed because this is just a very sparse and small number of nodes. So they came with this idea of what are called, and you may have heard of that even if you're not in the field, of small worlds, those are graphs, those are worlds that have a local structure, but they don't pay for that the price of being too extended, of being too long. Okay, so the question, so this is to set you, again, this is research we did some years ago now, 20 years ago, but I wanted to bring this to this table. We were there. We had the idea of chains, we had WordNet, and we had the emergent field of small worlds as something that, big question of how could it be that the networks that one found in nature could be made into small worlds. I'll skip this. Well, that's the last essence of graphs. There was one more, sorry, which is the notion of traffic. It's a very simple notion, but it's a very important one. If you see, I've colored here in this graph, this is just an example of a graph, and I've colored the number of nodes that they have. So these ones, they have 2 nodes. Oh, sorry, some have 1. And in green, you have the 2 nodes that have the largest number of neighbors. They have 4 neighbors. This is the largest in this graph. But it doesn't take a lot to understand that this one that only has 2 neighbors is the most important node in the graph. If it's not there, then the graph is cut in 2. And to go from one place to the other one, you have to pass there. This is what's called a center of traffic, or in English, a hub. And those are the essence of Google, of PageRank, of what Larry Page described, was that by identifying these guys, by identifying who were the points through which you have to pass to go, they don't need to be the ones that are more locally connected, but they're the centers of traffic, then assigning relevance of this was how Google was constructed. So now I'm gonna give you the example of how this can be used to try to understand the space of meanings and how the space of meanings is organized. So what you have here is a histogram of all the different, you take pairs of nodes and you measure how long does it take to go from one to the other one. And you see that the distances are between 10 and 15, so you could take just an average of that and it would be close to 12. And what you have in this cluster is for each node, you take how many neighbors it has, and then you build this neighborhood, and you see how much clustered it is, so how much they have close connections within this particular neighborhood. So the more connected it is, then the more likely, and this is logarithmic, this is exponential. And what you see from this graph is that when you start with WordNet, which we had because someone had done it for us, and you measure the graph properties of it, they're, from all the informational point of view, pretty bad. It's a graph that it takes very long. Making 12 steps in any graph is a very long distance, and there are no notions of clusters. So it's like a tree, from a graph theoretical perspective, is the worst of both worlds. You have to go all the way up and all the way down to go from one place to the other, so it takes very long if you want to link two different concepts. And at the same time, you don't have the notion of locality, of local structures or small-scale memories. Now, you can start growing the graph and you say, well, maybe the fact that steel relates to cars, but also it relates to boats and it relates to different things are the shortcuts that we need actually to make the semantic graph work as something that we know it's mathematically how it should work. But this does not happen. Again, this is something, you see from here that the distances are still too long, and clustering, essentially, if you see green close to this line, it means that it's very clustered, and if it's low here, that means that clustering is very low. And so the other relation that we had, and this is one that's going to be important for the last 20 minutes of my talk, was the relation of polysemy. So concepts are also related because often languages, and all languages, use the same word to refer to different things. And this seems very capricious. Why? I mean, it seems like a problem. People that do computational linguistics typically have the problem of understanding whether the word bank, which is the typical example, refers to a place where you extract money, or it refers to the side of a river. And for this, you need to see the word in context and place it. But why, in the first place, are all language polysemous? Is it that there are not sufficient words? Like we don't have enough combinations of, I mean, this is, of course, very far from reality. And again, it's something which is tremendously ubiquitous. So there may be a relation that polysemy is out there for a reason, and that's what we sought to see in this particular study. So what you see here is just, again, the tree of, so a living thing is an organism, a vertebrate, mammal, carnivore, and this is a canine, and this is a dog. So you have a canine and a dog, and you can go from a different branch of the tree. So you go a person, and persons are males or females, or it can be intellectuals. It's interesting, this division, like either they're intellectual or unwelcome. I mean, this is the graph that I got from the Miller. I think I've never seen that. And then welcome persons and villains are called dogs. And here, you have a link that seems capricious, but maybe it's not, where you do see the shortcut in the space of meaning. Something in the moral category of judgment is related with something on the organization of species, where we perceive and we map certain species as good or bad, depending on how we want to map them. And so we ask the question of what happens when we add a polysemy into this graph. And the point which you see here, once polysemy is added here, is that you see that this goes strongly to the left, so it becomes a very short graph, and all the green points go all the way up to the limit. So from this is a theoretical point, that the notion that including metaphors, that including calling different things with the same name, actually does this job of shrinking the space of meaning in a way that, at least from a completely a computational point of view, seems much more tractable. And the last point for this, which will be relevant for the next slide, is that when we look at the hubs are exactly the more central metaphors. So the body parts, the most abstract concepts. So just to give an example, because I think it's one that may answer this, and you'll see it quite clearly. When we say he's the right hand of the government, of course, the government does not have a right hand, and it takes a few seconds just to be sure of that. But what we are doing is that we are thinking the government, which is something that's very hard and abstract and hard. We don't know what governments are and how they are made and how they work. So what we do is we think of governments with a metaphor of something we know very well, our own body. And we think that they have a thinking entity, the brain of the government. We think that they have a strength, an agile part of it, the right hand of the government. And we use all the time metaphors to, again, this idea of shrinking the semantic space, to take branches that are ill-defined and very far and bring them close to a point where they become more accessible to be used for representations, memory, et cetera, et cetera. So with all this, and with the idea that we have that we can construct a space of meanings, we can go on, and this will be quite fast. It will be a shorter part of my talk. We can go on the idea of the very first question I posed of trying to understand, is the description of human characters throughout human history something that has progressed in their introspective content or not? Is there a non-stationary description of introspection in the history of the human record? So we go now to this being able to test that. And here what you have is an example, again, of and this is not done, this is not WordNet exactly, it's done with another method, but here it's not that relevant, and I'll skip how this is done. It's not completely necessary. And it's not a demonstration, but it's just a proof of concept. This is it's an algorithm that essentially what it does is it takes two words and it measures the conditional probability that they're together. So you go through all text of human history, all the text you have, a very large corpus. You take any two words, and when you take any two words, you measure the frequency of one, the frequency of the other one, and the shared frequency of the two. And if they're always together, then the conditional probability is very high. And if they're words that are rarely together, then the conditional probability is very low. And then once you have that, you have a notion of proximity. Words are proximal when they tend to occur together in text. You invert that, and then you have a distance, close to a distance. It doesn't have the triangle property, but you can make this into a distance. And then this is, of course, it's a space that does not fit in two dimensions. Because you have things like this word is close to this one, and this word is close to this one, but these two are very far. And in two dimensions, in Euclidean space, you cannot do that. So this is a space that has, it's more complicated, it's complex. And so you make it simple. Essentially, you project it to two dimensions by trying to distort it as little as possible. And this, when you do all that, again, it's an algorithm. No one has placed none of these words where they are. You get this. So this is the projection of some of these words using this algorithm. And you see very rapidly that when you see it's close to the problem I posed in the beginning of how these words would be represented in space if we think or if we try to make a realistic projection of how we represent them in our mind. So the first thing you see is that they're broken in categories, Wilkins and Feldbaum. So you have the scientific terms, they're right here. Here is the fruits. Here is the computer parts. Here are the sciences. and here the body parts in the center. So the body parts, which are the metaphors, the things that are used to link different domains, are in these different clusters in the center of the graph. You see, again, the notion of a hierarchy. So not only things breaking in categories, but in subcategories. So I said here were the scientific terms, but here you see that there are the more astronomical terms that are one part of this category, and the more, more scientific and non-astronomical terms that are here. And you see things that are, this is one I particularly liked. I mean, this was just choosing these words and throwing them there. There was no moving of that at all. But you see that the word astronomy seems to be a bit weird here, because I said those were the astronomical terms, these are the scientific terms, and actually there are the sciences there. But you see, actually, on a way, astronomy is where it should be, except that this is not two-dimensional. It should be like up outside of this plane, linking what it is. It's a science, so it should be in the yellow cluster, to what it describes, the astronomical terms. So astronomy, someone steps out of this graph because it has, it's the father of one particular category, and it belongs to one category. So this simultaneously is something that actually makes it quite complex in this graph. And once we have this is the essence. This is like the key bridge of all what I want to say. Once we have this, we can ask the question very easily of whether someone is speaking of something. I could take words, I project these words into this space. Again, I'm showing it to you in 2 dimensions, but it's not a 2-dimensional space. And I see how far these words are from anything I want to ask. So I can take, for instance, the dimension of positive emotional words and negative emotional words. This is a well-defined axis in semantic space. And I can see whether words tend to project more to this side or to this side. And I can measure, as people do a lot now, emotional content by seeing the projection of words to one particular axis, one particular dimension of semantic space. Or for instance, I could see how far I am from this neighborhood here. And I could give a word that's not presented here, the word, maybe, I don't know, the word lettuce, just to give the example, and it will be somewhere here, and I can ask how far it is from any of these clusters. So in the case of introspection, I don't have the figure here, I'm sorry, I forgot to put it, I just saw. But the words that are close to introspection are words that are very reasonable. Self, yield, reason, consciousness. Also, there are artifacts. For instance, the word Freud is very close to introspection, because this algorithm will pick. And of course, it's a word that was not present in the text 3,000 years ago. So you have to do some trimming, some handmade trimming to understand what are the links that are completely an artifact, so to say, or the links that will not appear in the past. And eventually, now you can take the text, the question I posed in the beginning of James now becomes to me a completely scientific and procedural question. And I'll show you the results now, but before I want to tell you exactly what we will do. We will take the books of different traditions, and the books are a stream of words, and these streams of words are dated in time. And what we will do is we'll take each one of these words and we'll project them to this graph here. So now words become a trajectory in a space. That's something where we can measure. We know to measure things in space. Their trajectories in space. And what we will measure with these words is how far they are from the concept of introspection. Even if they circle and they never say the word introspection, we can see whether they drift away or they drift close to the concept of introspection. And the hypothesis, Jane's hypothesis, which in a second I will say why it's the soft Jane's hypothesis, is that as time goes on, the concepts become closer and closer and closer and closer to the concept of introspection. So I'm saying, I'm converting Jane's idea of I read in a few quotes in these books to the quantifiable statement that if we take books in different traditions, then they will project closely and closely toward an attractor, which is an attractor of introspection. And so this is, now once this is said, this becomes very easy, and we did this in the Greco-Roman tradition and in the Judeo-Christian and many different traditions. I'll show these too, but we've done this in many different traditions. And so here you have the Homeric text and then the different Greek thinkers organized by authors. And if you're versed as I am not a lot, in Greek philosophy, you'll note things that are weird, and we'll go there in the point. But you see that there's a very clear, there's a significant and very clear, I'd said, progression of how texts become closer and closer to the notion of introspection. So in the y-axis, what you're seeing is this notion of similarity measured through, as I said before, through the conditional probability of two words appearing together. And you see this in the progression of the Greek text. Now, this is in the Bible. Dating in the Bible is much more difficult, and because it was not to the essence, the precise dating of different moments of the Bible. What we did is we just took the stream of words. So now, essentially, this is all the words. So we are assuming, which is not completely true. It's not only not completely true, it's an approximation which has it has problems, like all approximations, that ordering in the Bible is a proxy for time. So the newest words describe events which are more recent, so that there's monotonicity in the description, in time description of the Bible. And you see again a similar pattern, a weak transition, then a quite strong transition in the New Testament. And one thing which we liked is that if you need some answers for these things. And so if you take Confessions by St. Augustine, which again, if you read today in modern interpretations of this, many people think as St. Augustine as one of the founders of modern psychology, or at least of one of the persons that has dwelled the idea of introspection. So again, this method, which has errors, we could argue, I wrote there Plato and Aristotle on purpose because I think that the majority of people that are versed, again, would disagree with the fact that Aristotle was on this particular relation. But within this noise, and I'll go onto this in a second, on all the possible critics to this, I'll make them myself, and then I'm happy to take more. You see that there is a consistent pattern, which again has an idea or a sense or a feeling or a flavor of the James hypothesis, which is that throughout the course of time, the texts have revealed a content and a description which comes closer and closer to introspection. Now I'll do like Borges. Now that I've presented the idea, I will myself try to think, as I think we have to do in reasonable science, what are all the possible critiques, which are many, to this construction we're making. The first one is that this continues, and James' idea was that this was a monotonic increase. And actually, his idea was that the big transition, which is in the example I gave, was in between the Iliad and the Odyssey. That was where there was the biggest transition. And we find something which has the same relation of a progression in time, but it's very different. And then the other thing which we found is that you go on to the texts, then you find it's like the Romans did not learn anything from the Greeks. It's like they start, which is true in many ways. Like if you think on the... So here's an interesting idea. The data do not show. We find something of what was James' idea, but we also find a strong difference. It's a progression, but it's a punctuated progression with progressions throughout cultural developments, which then eventually go down in moment of social crises. And it's very interesting, at least to me, if you look at in the 20th century record, so this was the far history, as far as we can do it, of human text. Now we go to times in which we know better, and sorry, the scale, the axis for some reason should be there and it's not there. This is the 20th century that you're seeing here, and you see that, and what you're seeing is the closeness of all words to the concept of introspection. And what you see is that there is a progression, but within this progression there are two dips that even if the scale is not there, it's not very hard to guess that this corresponds to, again, the First World War and the Second World War. So you get an idea that there's a progression that in a way, the amount of introspective content of the integrated production of a culture is a reflection of its degree of peacefully, of stability, of development, of calmness, and I'll go into this into just a second. Now, there are two controls that one would like to do there. The first one, again, sorry I don't have the slide, it's on the paper, and I can show this slide if you want to throw the questions, is that you could say, well, what happened is that throughout the wars, or throughout the decline of the Greek Empire and the transition, essentially there was a banishment of all forms of human expression, and so this would be true for any other concept, and this is not true. If you ask for a complete whole set of random, the probability of getting something like this is extremely low. So we actually sampled, I think, in a rigorous manner, what is the likelihood of finding a pattern like this for if this would be just a random concept that we would be showing. The other thing which I think is technically important, and I would like to go this before going on closing this particular section, is what you have here is just counting the word introspection. And if you just count the word introspection, you see that maybe there's a bit of a trace there, but essentially that there's no pattern. So again, this is a technical point where I wanted to stress the second part of my talk, why I presented this, which is that to know that people are speaking about something from a completely technical and computational perspective, like if you're Google and you try to understand what someone is telling to you, or from a scientific perspective, counting words is a very poor proxy, it's a very poor estimate. We need something like trying to understand the structure of semantics. And so how am I in time? I close? Okay, so I was going to speak about the future of consciousness, but this will be for the future. But can I take 3 minutes? 2 minutes, perfect. So I would like to make myself, this is not the typical science I do. Typical science I do is more in the form of what you saw today. Instance, I bring subjects to the lab, and I have the freedom of asking them, well, within certain domains, the kind of questions. I can do experiments which are real experiments. This is, of course, not a real experiment. But to me, and I see that, and I'm aware of that, and I would like to present this as something which is very far from complete, but at the same time, at least to me, has the beauty of going into the really unknown and thinking how we can do science in this very far and remote unknown. And so what are the problems that, when I said the soft Janes hypothesis? Well, there are all sorts of problems and approximations of this. One, for example, is that, of course, this is not the integral of human expressions, but it's only written expression. And only a small number of people got to write. And not only that, but these books have been rewritten, translated, censored. So it could be that what we are seeing here, not so much in the 20th century, but in the old books, is not the reflection of human culture, but the reflection of human censorship and human selection and human willingness to show some things and not the other ones. Second fundamental problem is that this relies that these books are history, in a way, that there's some reality to how these books are described. This, again, could be completely wrong. Homer was a poet. And it could be that this is all fiction, and the fact that these characters change from non-volitional to volitional was just the change. It's like if I would take the songs of the Beatles, they changed maybe not because society changed, but because they changed their own taste. So all these things have an assumption, which is an assumption which makes this limited, as I think, all form of science, which is that assuming that there is history in these books, assuming that the distortions that we have, because these books have been rewritten, filtered, and selected, what we can show, the data shows, is that when we take these books, what we do find is something that resembles what James thought he had seen in these books, which is that, again, consistently, there is a transition from the description of this text from being completely non-volitional to being text that have a much more content of introspection. Thank you.